Exact nearest neighbor search reads every row in your table. At even moderate scale, that becomes unacceptably slow. pgvector gives you two approximate indexes, HNSW and IVFFlat, that trade a small recall loss for orders of magnitude faster queries. Exact KNN is correct, but scans the full table. HNSW pre-builds a navigable graph, so search hops straight to good candidates. IVFFlat divides the space into cluster lists and only probes the ones nearest the query vector. Both are approximate. You control how much recall you sacrifice. HNSW is a hierarchy of graphs. At query time, you enter the top sparse layer and greedily descend toward the query vector, arriving at dense candidate neighbors with very few distance computations. IVFFlat is simpler. Partition space with k-means, then at query time probe only the closest centroids and scan just those lists. 3 things kill pgvector performance in code review. First, no index exists at all, and every query does a full table scan. Second, ef_search is never raised from its default, so recall quietly degrades. Third, and easiest to miss, the operator class on the index does not match the distance operator in the query, so Postgres ignores the index entirely. Without pgvector installed, we model the partition probe idea directly. Filtering to the cosine partition and ordering by val descending gives us exactly 3 rows in deterministic order. In a real IVFFlat index, probing the wrong list returns a different incomplete candidate set, the same class of bug, just invisible without measuring recall. 3 review checkpoints. The index must exist, its operator class must match the query's distance operator, and the recall tuning parameter must be explicitly set. Miss anyone, and you either scan every row or silently return wrong neighbors, both failures that are hard to catch without a dedicated recall benchmark.